Imagine you have just eaten a meal. The carbohydrates in your food are broken down into glucose, that is sugar, which enters your bloodstream. As the blood glucose level rises, your pancreas starts monitoring it. Now, inside the pancreas, there are certain tiny cluster of cells called as islet of Langerhans. Now, among these islet of Langerhans, few specialized cells are called as beta cells. Now, these are the beta cells which are responsible for making and releasing the insulin. Now, let us see what happens step by step. In step 1, the glucose from the blood enters the beta cell through a special transporter called as GLUT2. Think of GLUT as a doorway that allows glucose to enter the beta cell. In step 2, the glucose is converted into energy. Once inside the cell, the glucose is broken down through glycolysis and it enters TCA cycle and further oxidative phosphorylation in the mitochondria, and it produces a lot of ATP, which is the energy currency energy currencies, which is actually the energy currency of cell. As the blood glucose increases, ATP inside the beta cells also increases. So in step 3, the beta cell has special channels on its membrane called as ATP sensitive potassium channels. Now, normally these channels remain open, allowing potassium ions to flow out of the cells. This keeps the inside of the cell electrically negative. But when the ATP level rises, ATP binds to these potassium channels and inhibit them. Now, potassium can no longer leave the cell. In step 4, the cell membrane becomes depolarized. Since potassium is trapped inside the cell, the electrical charge across the membrane changes. The inside of the beta cells become less negative, and this change is called as depolarization. You can think of depolarization as switching on the electrical signal of the cell. In step 5, the calcium channel open. Depolarization opens voltage gated calcium channels. Depolarization happens and the calcium rushes into the beta cells because calcium concentration is much higher outside the cell than the inside. Calcium triggers the insulin release in step 6. The rise in the intracellular calcium acts as the final signal. In step 6, insulin is already stored in tiny membrane bound sacs called as secretory granules. Calcium tells these granules to move toward the cell membrane and fuse with it and release insulin outside by exocytosis. Insulin enters the bloodstream. The released insulin enters the blood and travels throughout the body. It binds to insulin receptors on the muscle cells, fat cells, and liver cells. Muscle cells take up glucose for energy. Liver cell store glucose as glycogen, and fat cells store excess energy as fat. This lowers the blood glucose level back to normal.